In this video, we're going to look at graphing the function y is equal to 3 over 2 secant of 2 over 3x. Now, I'm going to be switching back and forth from the Alex view so we can see how to graph it in Alex, and then going back to the view where we're going to do our work. So we have 3 over 2 secant, 2 over 3x. So the first thing I would do if you're graphing a secant or a cosecant is just remember that secant is 1 over cosine. And so just kind of keep that in mind. I'll put that right here. In general, secant x is equal to 1 over cosine x. And so what that means is what we're really going to do first of all is we're going to graph cosine x at the start, and then we're going to use that to come up with the graph of our secant function in this case. And of course, if you wanted to change, 3 over 2 is the coefficient in front of secant and the cosine, and the 2 over 3 in front of x inside of the argument, you could do that. But just in general, you just want to know that cosine is the thing you're shooting for. And so what we're really wanting to graph is we're really wanting to first of all graph y is equal to 3 over 2 cosine 2 over 3x. And so what's important is that we're able to pick out the a and the b, because for this problem we're going to have an amplitude other than 1, so that's going to be an adjustment, and we're going to have a period that is also modified from the normal just cosine function. And so for our problem we have an amplitude, absolute value of a, our a is 3 over 2, and so our amplitude is 3 over 2. And so that means that we're going to be going basically 1.5 above and 1.5 below. That's 3 over 2. So the overall distance that we'll have from our lowest to our highest point is 3. Now our period is going to be 2 pi divided by b, and for this problem b is 2 over 3. So we'll have 2 pi over 2 over 3, and if you multiply that, think of it as two fractions divided by each other. You can multiply by the reciprocal of the denominator. The 2's are going to cancel, and you'll get 3 pi. So every 3 pi, let's kind of interpret what that means. Every 3 pi, this function is going to completely go through its entire cycle. And so for cosine, for instance, when we sketch the graph of it, cosine starts right here. It's going to go down, and it's going to go back up. And as soon as it reaches that high point again, that's going to be the 3 pi, because that's one period. Now, we don't have a phase shift, so we're still starting at the normal value. The highest point of our cosine is going to be on the y-axis. Now, we need to figure out what these critical points are. In other words, where we run into the x-axis here, and what the low point is when we run into the x-axis here. But the way we can do that is we can just take 3 pi and we can divide it by our 4, because that'll give us our 1, 2, 3, 4, what the spacing is between all of those. And so 3 pi divided by 4, of course, is just 3 pi over 4. So every 3 pi over 4, something is going to happen. And so what we're going to do when we get back over into Alex is we're going to count off on the x-axis. Basically, it's divided into like pi over 4 sections. So this first 3 pi over 4 section will be an asymptote, because if we graph the cosine that corresponds with this, that's where we run into, of course, the x-axis. So we have a y value of 0. So, of course, 1 over 0, if you do the reciprocal of that, is going to be 1 over 0, which is like infinity. So it's an undefined point, and so that's why that's going to be an asymptote. So basically, anytime you're doing your cosecant or your secant graphs, wherever your sine or your cosine function that you're using to kind of get to the graph, wherever it runs into the x-axis, that's going to be a vertical asymptote. And so what we're going to do is we're going to count off the first 3 and put a vertical asymptote. Then we're going to count off 3 more. That's going to be the low point, and then 3 after that will be another vertical asymptote. So after the first 3, it's every 6. And so let's go over here and let's go ahead and put those into the function, or into the graph rather. So like I said, we're going to count off 3 pi over 4. So 1, 2, 3, and put a dot, or our point. And so that's going to be the first vertical asymptote. And then we're going to go 1, 2, 3. That's going to be the low point. 1, 2, 3. That's going to be the next vertical asymptote. 1, 2, 3. That's going to complete our cycle. We're going to go through the whole thing. That's one whole period. Then 1, 2, 3. There's our third vertical asymptote. So it wanted 3 consecutive asymptotes and 2 points, 1 on each side of the second asymptote. So now let's go ahead and figure out what those values are going to be, 1 on each side of the middle vertical asymptote. So going back here, then red is what our graph of our secant is going to look like. Basically, they meet and touch each other right there, but then this one goes up toward infinity. So they'll meet right here, and it'll go in that direction, and it'll meet right here and go in this direction. Now, really, I'm going to go ahead and push this out a little bit further, because we're interested in what's happening on either side of the middle vertical asymptote back over in Alex. So let me get this in blue, if it will let me. that's our third vertical asymptote over an Alex. And so basically what we want to show is we want to show the points on either side of the middle asymptote. So we're interested in those two regions in red. And that would be the graph of our 3 over 2 secant 2 over 3x. So let's go ahead back over there. We need to figure out what these points are, but we already know because those points are meeting, they run into the place where we have our 3 over 2 cosine of 2 over 3x. And so that point right there is going to be the point, here I'll show you over in Alex. We know it's going to be right here. That's going to be at 3 pi over 2, and it's going to be at the point negative 1.5 because our amplitude was 3 over 2 or 1.5. And so then clicking right here, we know we want to have an x value. Take me a second to type this in. We know we want an x value of 3 over 2, 3 pi over 2, so we can just say 1.5 times pi. And then we can do our y value, which is going to be negative 1.5. And that comes again from the amplitude. Now those are exact decimals, so it should be okay with us plotting those points. So there it is. And we also want another point to the right of the second asymptote. So let's go back over here into our little scratch work area. So what we're interested in finding now is this point right here. And we know that's going to be an x value of 3 pi and a y value of 3 over 2 instead of the negative 3 over 2. So again, let's do this right here. We're going to type in 3 pi as our x value, and our y value is 3 over 2 or 1.5. Again, whichever one you want to put in there will be good. And there are 2 points, one on either side of our middle vertical asymptote. And so now we should be able to click our graph button and see what happens. And there you go. You can see that that is what we would expect it to look like, going back to what we saw in our little scratch work area, and we can check it and make sure it looks good. And that's it. So the idea is when you're doing this, I would definitely sketch out the version of, in this case, secant is 1 over cosine. So sketch out the 3 over 2 cosine 2 over 3x. And basically anywhere that function runs into the x-axis, that's going to be a vertical asymptote. And all of its high and low points, in this case it wanted one on either side of the middle asymptote, those are going to be places, I'm going to go back real quick, those are going to be places where the two functions run into each other and meet. And so whatever value, in this case the cosine had at the low and the high point, the secant is going to have the exact same value or the exact same point. So I hope that was helpful. If you have any questions, please let me know.